Hello friends, Mr. Burrell here. We're in the middle of Unit 2. We're nearing the end. We're almost towards our last lesson. We've talked about kind of the basis behind statistical studies and research, how to identify populations and samples, how to identify variables and study methods. We've talked about how to sample our population in a way that is unbiased. We've talked about creating histograms so we can visualize our data. So now we're going to talk a little bit more about analyzing the information that we've gathered and how to determine why it's important, what it's telling us, things like that. So today in 2.4, we're going to talk about center and standard deviation. Some of those words might be a little bit foreign to you. That's okay, but we're going to talk about our data that we've collected and analyze center and standard deviation. So by the end of this video, by the end of this lesson, hopefully this is what you're able to understand. I want you to be able to understand what a standard deviation is and how it relates to the average of a data set. I want you to be able to calculate the standard deviation by hand and also understand how to find it using a calculator. We'll discuss that. And then I also want, we're going to talk a little bit about this, about the normal curve and how it relates to a density histogram. But we'll talk about more about that in the next lesson, in our next video. So those are the things that I want you to be able to understand by the end of this video. So some definitions. Some of these you'll know, some of these you won't. The first one is the mean. We're talking about measures of center. So the mean, or the average, is a center point of the data set. So I find the average, or the mean, of a bunch of numbers, a bunch of values, by adding all the values of a data set, adding them all together, and dividing by how many total values there are in the set. So if I wanted to find the average of the numbers 1, 2, 3, and 4, I'd add all those numbers together, 1 plus 2 plus 3 plus 4, which is 10, divide by 4, because that's how many total values there are, and I'd get 2.5, 2.5. So that's how I find average. It's a measure of center, kind of right in the middle of the data. And I find that by adding all the values up and dividing by how many total values there are. The range is the difference between the largest and the smallest values of a data set. So in this example right here, really easy, small example, the range would be the biggest value subtracted by the smallest value. 4 minus 1, which would be 3. That would be the range. It's just the difference between the largest and the smallest values of a data set. Kind of gives me an idea of how wide, expansive the data set is. So standard deviation, this might be a word that is less familiar, that you haven't really heard much before. Standard deviation is the measure of how far away or spread out the data is from the mean. So I have this mean, 2.5. Standard deviation is a measure of how spread out the data is from the mean. And we're going to talk about why that's important and how we can find it. So here's the scenario. You are choosing a new player for your intramural basketball team. Here are the point stats over 6 games of 2 separate people you want to play on your team. Which player would you choose? So say player number 2, that's Mr. Burrell. That is I. This is player number 2. And player number 1, say that's Mrs. Nilsson. She is player number 1. So you can see here, Mrs. Nilsson seems pretty consistent. Game 1 through 6, she scores 10 points every game. Boom. Killing it. Crushing it. Consistency is key. Mr. Burrell, in the first game, seems like he's killing it. He got double the number of points that Mrs. Nilsson got. But game 2, I only got 0. Game 3, 15, 8, 5, and then 12. So it's a little bit more sporadic. So what do you think? Which player would you choose? Would you choose Mrs. Nilsson? Or would you pick Mr. Burrell? Who's going to award you the most points? And how are you going to determine what that's going to be? So for example, if I wanted to find the average of these 2 sets of data, that would kind of give me an idea of who's going to score the most points. So okay, let's take the average for Mrs. Nilsson. Well, 10 plus 10 plus 10 plus 10 plus 10 plus 10 is 60. 60 divided by 6 games, 6 data values, is 10. So the average number of points that Mrs. Nilsson scores per game is going to be about 10 points. Okay, let's find the average for Mr. Burrell. 20 plus 0 plus 15 plus 8 plus 5 plus 12. Go ahead and do that in your calculator if you need to. That is also 60. 60 total points divided by 6 games. Mr. Burrell also has an average of 10 points per game. So who would you choose? It's hard to tell because the means are exactly the same. The ranges will be different. The range for Mrs. Nelson is just 0 because the largest and smallest data values are the same. The range for Mr. Burrell is 20 minus 0, which is 20. So his data values, his points are a lot more spread out. Who are you going to choose? So what we're going to talk about today, we're going to be talking about standard deviation. Standard deviation is a statistical measure that can be used to help me analyze exactly how spread out data is. So you notice these ones, Ms. Nelson's points, aren't spread out at all. Mr. Burrell's are way more spread out. I'm going all the way from 0 points in some games to 20 points in other games. So standard deviation is a measure of how spread out data values are. Okay, let's see if I can move my face out of the way here. I'll move it down here for a moment. Okay, so for example, here's another scenario. This is in your guided notes. Which class did better on the test? So I have 2 classes. I have class 1 and class 2. I gave out a test, and these are the scores that students got on the test. So in class 1, someone got a 50%, 70%, 90%, 45, 95, 73, 67. Class 2 got 68, 65, 70, 75, 72, 69, 71. Right off the bat, kind of think to yourself, who do you think did better on the test? Who do you think did better on the test? Well, right off the bat in my brain, I see here, wow, someone got a 95% in class number 1. No one got nearly that high in class number 2. But also class number 1, someone had a score of 50%. That's pretty low. No one in class 2 got quite that low, so how do we determine who did better? So, let's take a look at this. The steps that we're going to follow here, step 1 through 5, this is the steps that we follow excuse me, to find the standard deviation of a data set, the measure of how spread out these data values are. So first I'm going to find the mean. So I find the mean, again, by adding all these data values together. I add all these data values together in each separate data set, and then I divide by how many data points there are. There are 1, 2, 3, 4, 5, 6, 7 data points in each of these. So I'm going to take my handy-dandy calculator. You can use your phone, you can use Desmos, you can whatever you want. I'm going to take 50 plus 70 plus 90 plus 45 plus 95 plus 73 plus 67. That's 490 divided by 7 total data values. That's going to give me a mean of 70. So the average number, the average score on the test is 70% for class 1. Class 2, I'm going to take 68 plus 65 plus 70 plus 75 plus 72 plus 69 plus 71, and I get 490. So 490 divided by 7, I get the same average for both classes. They both have an average of 70%. Okay, so step 2 in finding standard deviation, I'm going to find the difference of each point from the mean, or the distance of each point from the average. So I'm going to take this first value, 50, subtract 70, which is going to give me negative 20. I'm going to take 70, subtract 70, which is 0. 90, subtract 70, which is 20. 45 minus 70 is negative 25. 95 minus 70 is 25. 73 minus 70 is 3. 67 minus 70 is negative 3. So I found the difference of each of those points from the mean. Excuse me, or the distance away. In class number 2, I'm going to take 68 minus 70, which is negative 2. 65 minus 70, which is negative 5. 70 minus 70 is 0. 75 minus 70 is 5. 72 minus 70 is 2. Negative 1. 1. Those are all the distances from each of my data values away from the mean. So you can kind of already tell this data set over here, class number 2, they're all a lot closer to the mean than these values are. Like I have some values that are 20 or 25 steps away from the mean, where in this set they're only like between 0 and 5 steps away from the mean. Okay, step 3 in finding the standard deviation, I'm going to square all the differences. I'm going to multiply each of these numbers by themselves. So negative 20 times negative 20 is 400. 0 times 0 is 0. 20 squared is 400. Negative 25 squared is 625. 25 squared is 625. 3 squared is 9. Negative 3 squared is 9. Notice that all these numbers are positive. When I square or multiply all these numbers by themselves, I will always get a positive number. When I square all of these numbers, I get 4, 25, 0, 25, 4, 1, and 1. So now that I've found the squares of all these differences, I've found all these positive numbers, the squares of all the differences of those data points from the mean. Now I'm going to find the mean of each of those squared differences. I'm going to find the average of all of these numbers. Okay, I'm going to take the average of all of these numbers. So I'm going to go ahead and take 400. I have my handy dandy calculator again. 400 plus 0 plus 400 plus 625 plus 625 plus 9 plus 9, which is 2,068 divided by 7 is about 295.43-ish. So I found the average of all of these squared differences here. Next, let me take 4 plus 25 plus 0 plus 25 plus 4 plus 1 plus 1. That's equal to, oh, I did that wrong, equal to 60. So if I find the average of all those, I take 60 divided by 7, and I get 8.57. Okay, let me move my face out of the way again so you can see what's going down here. So that was step 4 in finding the standard deviation. I found the average or the mean of all of those squared differences. Now, last step. Since I squared all these numbers earlier, now I'm going to take the square root. So, the square root of 295.43, the square root of 295.43 is equal to 17.2-ish. And then the square root of 8.57 is 2.9. The square root of 8.57 is 2.9. So those numbers represent my standard deviation. Those are a measure of how spread out the data values are from the mean. How far away are those data values from the mean? That's how I find the standard deviation. The typical symbol that people use to denote standard deviation is this. It's like a little O with a hat on the top. That means standard deviation. So the standard deviation in both of these cases, this is the Greek letter for sigma. The standard deviation is much higher. These values are much more spread out than these values are. So now, which class do you think did better on the test? They both have the same average, but it seems like this class was much more consistent, where this class was more all over the place. So in my opinion, I think class 2 probably did better because everybody was more on the same page. There were some people that did score higher in class 1, but there was too many people that scored really low to consider that everyone did okay. So that's how I find standard deviation. So this number, again, this number is the standard deviation, or how spread out the data is from the center of the data set. Okay. So I have this graph here. When we talked about histograms, say I have like a histogram that I draw under this little curve. If I were to draw a histogram, a bunch of bars under these little curves, I want you to kind of ask yourself, which of these like rounded histograms has the smallest or the largest standard deviation? So notice that this big red curve is really like wide and short. It's really spread out. So there's going to be a lot more spread. There's going to be a lot more variety in those data values, which is why the standard deviation is larger. This really tall, skinny one, it's much more spread out. All of the data values are right in the middle, right really close to the mean, right really close to 100 here. So that standard deviation is going to be a lot smaller. It's a lot less spread out. Where this one in the middle, this pink one right here, is kind of right in the middle. It has a standard deviation between those two. So visually, that's kind of what standard deviation looks like when we're kind of reflecting back on our histograms. A really spread out histogram is going to have a higher standard deviation. A really narrow, skinny histogram is going to have a smaller standard deviation because it's less spread out. This curve right here, we're going to talk about this a little bit more in the next lesson, resembles the form of a normal curve. We're going to talk about what that means a little bit later in the next lesson, but keep that term in your brain, the normal curve. Okay, so some things about the standard deviation. First of all, it's a distance, so I'm measuring from the mean to a data point in the data set. So when I'm talking about standard deviation, I'm talking about the distance on average that a data value is away from the mean or the middle of that data set. That being said, a standard deviation is always positive. A distance can't be negative. If we go back and we talk about the process that we followed to find the standard deviation, remember I took all those differences and then I squared them so that they all became positive. A standard deviation will always be positive because a distance cannot technically be negative. So some properties of standard deviation that will be helpful in the upcoming sections. So, coming back here. This was kind of a process to find the standard deviation for each of these data sets. So I'm going to show you how you could find this in your calculator or on the computer. So hopefully you can kind of see my screen a little bit. I'm going to show you on my calculator how to find the standard deviation, and I'm going to show you on the computer how to find the standard deviation. So in here on my calculator, there's this stat button. So I'm going to click this stat button. And then the first option is edit, so I'm going to click edit, enter on the edit option. So notice in here, in this first little list, L1, I have typed in all the data values from this first class. 50, 70, 90, 45, 95, 73, 67. 50, 70, 90, 45, 95, 73, 67. So I have all these numbers in this list. If you don't have them in the list, you could enter those all in and then click enter. And go all the way down to the bottom and click enter. Okay, next thing I'm going to do, I'm going to come down here and I'm going to click Stat again. So in this Stat menu, if I click to the right, under this CALC option, it says 1-var stats. That stands for one variable statistics. So I'm going to go ahead and click 1. So here, I'm going to select the list that I want to use. So if I click on my calculator, let me get down here. If I click on my calculator, the second button, and then down here under the 1 option, depending on the calculator you're using, this might look different. Under the 1 option, above it, it says L1. So I'm going to click L1. Usually the calculator will just automatically select that option, but I've selected list 1, so I'm going to click enter, enter, and then on calculate, I'm going to click enter again. So on this menu, there's a lot of things that it tells you. At the top, this little X bar, that's the mean or the average. The average was 70. And then down here, you see this little 0 with the hat, the little sigma sign. That's my standard deviation, 17.2. And down here, when I found it by hand, my standard deviation, the measure of how spread out the data was 17.2. So that's how you can find the standard deviation in your calculator. Every time you find the standard deviation, you don't need to do it by hand. But I did want to show you how to do it by hand in order so that you kind of appreciated the process and saw why and how we find it that way. So now I want to show you, if you don't have access to a calculator at home, if you just search like standard deviation calculator on the internet, you'll find like an online standard deviation calculator. So I searched standard deviation calculator, just like clicked on the first option, and I'm going to find the standard deviation of our second class. So my second class scored 68, 65, 70, 75, 72, 69, and 71. So I just typed in all those numbers, separated by a comma, and make sure this little population button is selected. And I'm going to go ahead and click calculate. So the standard deviation is 2.9. And if we go back in here, look here, my standard deviation of that set was indeed 2.9. See that? So, and I also find that the mean is 70. Standard deviation 2.9, mean is 70. So again, every single time you find the standard deviation, you don't need to do it by hand. But there's some tools out there to help you find the standard deviation. But it's important to recognize that what that number is telling me is a measure of how spread out my data values are. Okay. So I want to look at a few homework problems. That's technically the end of this video, but I'm going to go over a couple of the homework problems with you here so you can kind of get an idea of what's to be expected on some of these questions. There is a section on the homework where I do want you to find some of the standard deviations by hand, and then some that I just want you to find them using the calculator. You know how to do both now. So number 4, for example, on the homework says, which of the 3 data sets shown on the graphs to the right has the smallest standard deviation? Justify or explain how you know. I showed you a graph similar to this earlier, but a small standard deviation means that the data is not very spread out. So the graph on here, this little rounded histogram, this little curve right here, seems to be the least spread out. It's all the data values are kind of bunched towards the middle, right? That means, visually, that helps me know that that curve has the smallest standard deviation, with sigma equals 0.5. Standard deviation equals 0.5. And I know that because all the data values are like smashed into the middle. All the data values are smashed into the middle, or however you would want to describe that curve. Into the middle. All the data values are kind of scrunched into the middle. That's how I know it has the smallest standard deviation, because it's the least spread out. Okay, a couple more questions. On the back, it says, decide whether each statement is true or false. If false, state why and give an example. So we're I've chosen letter C and letter F. So letter C, it is possible to have a standard deviation of -3 for some data set. Is it possible to have a standard deviation of -3 for some data set? Well, this is going to be false. Remember, I mentioned earlier on this slide right here, a standard deviation is always positive because through the process of finding the standard deviation, I square or multiply by themselves all the differences from each of those data values from the mean. When I square them, they always become positive. Since the standard deviation is a measure of a distance from the mean, it will always be positive. So the standard deviation will always be positive. Standard deviation will always be positive. Okay, so letter F. This is the last homework problem I'll go over, and then if you have questions, you can let me know. Suppose a data set has an average of 58.2, so this is the average, and a standard deviation of 3.84, and that there are 10 values in the data set. If all 10 values are decreased by 4, the new standard deviation will still be 3.84. So what do you think? If I were to just subtract each of my data values by 4, do you think the standard deviation is going to be the same, or do you think it's going to be different? So let me show you an example to kind of help you visualize this. I'm going to go back to my standard deviation calculator. Say I have the data values, I need to choose 10 of them, right? That's what the question said. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let's find the standard deviation of that data set. The standard deviation is 2.87. Okay. So that's the average distance that all of these values are away from the mean, or the average. The average is 8.5, and on average, all of the other values are about 2.87 units away from that middle point, that mean, that average. Okay, well, let's subtract each of those numbers by 4. That's what the question said, right? If each of those values are decreased by 4, will the new standard deviation still be the same? So 4 minus 4 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each of those values subtracted by 4 will give me 0 through 9. What do you think? Is the standard deviation going to be different or the same? Is how spread apart these values are different or the same? Well, notice I'm still like My largest and smallest numbers are still only 9 units apart. The range is still only 9. 9 minus 0 is 9, just like 13 minus 4 was 9. So they're not like it doesn't seem like they're going to be any more spread out. My thinking is that the standard deviation is going to be the same. Let's see. Alas, it is. Even though the mean is different, all the data values are still the same distance away from the new mean. So the answer to this question would be yes. The new standard deviation is still 3.84 because the data values are all still the same distance away from the mean. Their spread is still the same. So, I don't know. Their spread is still the same, or something like that. So that's all I've got for you. That is the end of this video. Hopefully now you understand what standard deviation is and how it relates to the average of a data set. Remember, the standard deviation is a measure of how far away different data values are away from the mean. On average, how spread out are all the data values in my set away from the average point. Hopefully you're able to calculate the standard deviation by hand and using a calculator or a computer application. And hopefully you're starting to understand what this little curve means, what this little normal curve is, how it relates to a histogram. We're going to talk about that more in the next lesson. So I hope that was helpful. If you have any questions, please don't hesitate to reach out to me and let me know. And I hope that you enjoyed that as much as I did.